Happy Friday, everyone. Today is June 22nd, and this is episode 40 of Get Your Tech On, our show on all things DOCSIS. I'm Brady Volp, founder of the Volp firm and Nimble This. With us is Mia Calabrese, person who spent her entire cable life in cable.
I spent my
entire adult life in cable. Yeah. Mia, good to have you on the show.
Thanks, Brady, for that introduction.
Yeah, well, I try to do my best. Also with us is John Downey, whose motto is "Let's pump you up." John is also technical leader in Cisco Systems. John, great to have you with us.
It's always great to be back. So I could tell, everyone could tell this is not scripted, with some of that in.
It is like so funny. Like, what?
So, today's topic is ANGACOM, and we are going to be covering things like DOCSIS 3.1, Intel, FDX, R5, big data, orchestration, timing. We've got a lot of topics to cover. We're going to start off the conversation with a very short video that we've put together on ANGA, which, John, you're not going to be able to see this, but we'll talk through it. So this is just kind of give everyone just a little overview of what we see at ANGA.
A little taste of what's at ANGA.
And it might be good anyway, because if there's people listening to this as a podcast, then it'd be good for you to kind of talk through
it. Right. So really what we're showing, we stopped by the Aris booth and we visited Tal, who has also been on the show. Yeah. And she walked us through her orchestration, which I think Brady could talk a little bit about too. They're doing some really interesting stuff with their CMTSs, which is kind of interesting to see if Cisco is also doing something similar. Yeah. Do you know?
I think they are, and we can talk about that. But I mean, we covered orchestration before. It's just really, really beneficial to have it as we get into more complexity.
And it'll be nice too, because like what they're doing is basically, instead of having to have people go in and get all this Aris training on how to actually program in CMTS, a lot of it now will be done automatically.
Yep. So then
we stopped by their Harmonic booth, and we saw, I don't know, John, if you remember when we all worked at Secor Electronics.
Of course.
That
all of us together.
All of us together.
Yes, all of us.
So we stopped by and we saw another old Secor employee at Harmonic's booth. We did also look for Asaf. And every time we saw Asaf, he was like busy talking to people, so we just never actually got a chance to catch up with him. Another booth we were at was the VX booth, and it was they had some interesting stuff to show too.
Interesting people.
And it was we also always got photobombed by Mike Collins. So
yes,
very nice.
Lots of booths.
And then we also, one of the coolest things actually is not really technology related, but it was Legos. And they had like to celebrate the World Cup, they had a big stadium, they had the Village People, they had like a little bar, they had Star Wars and Batman, they had zombies, and they also had
there was one of my favorite was this guy vomiting, and so that was pretty cool to see.
They actually made a Lego guy vomiting in front of the stadium. And then now we're at the Cisco booth, and there's a picture of Brady and John looking quite serious.
Yeah.
Then the next thing John
you're
is
posing,
doing
John.
is posing.
And then there's Mia talking, and then me presenting at the big data presentation.
Yeah, and then some more pictures of us with John and also Ron Rannick.
Yeah, Ron got in there too, and then finally exiting the show.
Right, and the show was really good. I would say it was really. I like the new layout. I liked it from last year. We did have some bad weather while we were there. It was raining a lot, so
it was much cooler ANGA.
Yeah, but that actually I didn't mind, because it's usually really hot in those halls, and I'm not sure they have AC. So I actually was okay with it.
Yeah.
Yeah, I mean, it was my feet hurt. There was a lot of walking.
It was a lot.
The carpet they put down between in the aisles is not carpet. It's like a ShamWow. It looks like a ShamWow. What is this? It's feet hurt. But I'll tell you what, we need to give a shout out to everybody that's come up to us and said, hey, I saw you on your Google Hangouts. I really appreciate it. And I think it bodes well to the fact that we're just trying to disseminate information. We're not trying to sell anything. We might be technical guys talking about technology. I work for Cisco, but I'm not really pushing Cisco. I'm not a sales guy. We're just talking about DOCSIS. Just like you said, DOCSIS, everything DOCSIS. We'll talk about it.
And it's nice.
Definitely a big thank you to all of our subscribers and listeners. We definitely appreciate everyone. And also everyone who stops and says hi and thanks for listening.
And I would even like to just thank like some of the other vendors that have also come on, because it was funny. I was talking to someone and I was like, oh, I want to do this hangout. And they're like, aren't they a competitor? And I was like, yeah, but we're all technical, so why not talk about it? Like, there shouldn't be a problem. Maybe you don't want to get 4 sales guys on this call, but, like, I'm not sure how far that would go.
We don't do slides, and anyone that's in sales or marketing, that would just kill you. Here, you're just talking about technology and what you might have to offer, what you see in the industry.
Yeah.
So
speaking of technology, I think there was a lot of interesting technology at ANGACOM. I think some of the things that I saw was really, compared to last year, was a big maturity on the technology. So like last year, there was a lot of, it was sort of an introduction of RFI. And this year, it was a big maturity of RFI. So things have really come to maturity. What was your perception, John?
I was there early to help set up our booth, our demos, and then tear down. So I was there for the whole week. It was a long week. A lot of and beer just to make the week. So it was good, but I didn't get to see a lot of other vendors. I was spending all my time. But you're right. The stuff we showed was showing now that it is mature. We have stories now, best practices. Of people actually utilizing it. The only thing new, I think, that we really showed here, and Brady, you and I have talked about, is mobile backhaul, low latency DOCSIS. How do I eventually get 5G or even 4G mobile backhaul over a DOCSIS network? Having my cell phone in my house and using my DOCSIS as a backhaul, and really that's not the case. It's more like, I want to put in 5G into an area that 5G is going to be higher frequency, more attenuation. Cell sites need to be smaller, but I can't afford the right-of-ways and put up a cell site. But there's DOCSIS everywhere. There's DOCSIS modems. Can I have a hotspot, an access point hanging off of a pole, and use Wi-Fi or use that as a backhaul for a small cell site? And potentially, yes. The question then comes up is timing. And in the spec, there's multi-queue. I think you brought up active queue. Management. AQM, I think it is.
Yeah, AQM.
Yeah. So there are things in the spec already, and we showed some of that. More of a glorified presentation. There's not much of a demo in regards to the mobile backhaul, but we showed that at our booth that we do have a low latency answer to that question. We have an answer to the low latency question. And we also showed orchestration and automated. If we go remote PHY, which system they're going remote PHY, there's going to be a lot of devices out in the field that you're not going to put in manually one by one into a configuration. So going from CLI, command line interface, to a GUI is imperative. And I end up with GUIs, smartphone apps that log in a QR, lat long GIS location when you put the node on the pole, automatic configuration. And once you get everything set up, you're going to have to also say, all right, I want to allocate more bandwidth to this node because the World Cup is going on and it's a college town or it's a bar, and I need to access more capacity on the fly. And so I could do that on the fly now if everything is orchestrated well, everything's in software, the hardware is already out there, I just turn it on. We also showed, on top of that, a different way of doing licensing. It's called Infinite Broadband Unlocked, where we do have a customer in North America that's looking at this where everything's pretty much in the open. You can turn on everything you want, but the licensing is really based on how many subs and the WAN traffic, not how much you have on the DOCSIS side of the network. So you can turn on all your DOCSIS 3.1 spectrum, all your video, all your DOCSIS, and we're looking at really the backhaul traffic over months or weeks and a negotiated price. It's a different way of doing a license instead of paying up front. Because you could see, like, what if one customer signs up for 1 gig service? I have to turn it on completely, but only one guy's using it. Well, to force you to buy it just for that one guy, it could be hard to swallow. It's a big cost. There's a different way of doing licensing. We showed that. We showed FDX in its maturity, but it was really something we showed last year, a different side of FDX, and that's sounding. How the CMTS tell the modem to transmit while other modems listen, and then we can tell which modems will interfere with each other, because FDX means upstream and downstream transmit at the same time. So we can do the sounding as part of the spec that says, send a signal from all the modems, let the other modems listen, and find out how to goes into different transmission groups. Sorry, I was long-winded on that.
Yeah. You covered a lot of ground there. I think you covered just about everything we want to talk about in the show. Yeah. I'd like to kind of roll back with one of the cool things that I saw, and I'm interested if you guys are working on anything like this. And it goes back to sort of the one-button touch for CMTS configuration, and I thought this was kind of cool. Is one of the things we saw. And it kind of gets into we've been working on CMTSs and configuring CMTSs from the command line for forever, since CMTSs were configured or were first built. So we see with like orchestration and stuff like that we have the ability to just almost push a button and push the whole configuration into a CMTS without having to go into the command line. So is that something that you see happening from your end of the world?
Yeah, with cloud native, that's another thing we just announced about 2 weeks before ANGA, however you pronounce it, was cloud native CMTS. And with cloud native, you basically don't have a CMTS core anymore. You are assuming remote PHY devices are talking to a server that's running CMTS type of code, but it's not based on CLI anymore. What could be concerning is not the configuration, because the configuration could be all GUI based. The concerning would be troubleshooting. How do you do show commands? Like all the show commands I use today might be obsolete. So there's different ways that are going to be needed for troubleshooting. Is that bird pooping on me?
I didn't even notice you had a bird on your shoulder, John. I mean,
where did that guy come from?
And why isn't it better trained? So for our listeners, John's been sitting here with a bird on his shoulder the whole time. Is it a cockatoo?
Yeah, it is a cockatoo.
Just leave him there.
So the troubleshooting could be different because there's no real show commands, but everyone seems to be going towards IPDR and SNMP, troubleshooting via SNMP or IPDR, grabbing the information, or information's being pushed to a server somewhere, and then you organize that information into more realistic troubleshooting. As an RF guy, there's about 6 or 7 commands on the CMTS I like to run for RF troubleshooting, but to me, I shouldn't have to do 6 or 7 commands. I should be able to write a script to say, grab me all the RF-centric information from the CMTS, put it into one output. Kind of like what you do for PNM stuff, right?
Yeah, and I got to tell you, I've been doing a lot of those type of scripting in like either Perl or Python already with CMTSs. So I'm really happy to see that even just the ability to program a CMTS will come from a fully automated standpoint, because I think the more we can do that, the less problems we're going to have just from an optimization and configuration standpoint moving out. And we'll be able to utilize a lot of best practices in the future, because it's just going to be automated. So having someone program a CMTS incorrectly, I mean, it'll probably still happen initially, but as we get best practices put in, like, you and I have the sort of best practices for modulation profiles and stuff like that, we want to get that stuff integrated so everyone starts to use DOCSIS better and better and better over time. And I can just see that happening as it gets automated.
I mean, well, even when we go cloud native, some people call it virtual CNCS, whatever you want to call it, because right? Kubernetes, containers, open RPD, open source, whatever. Now I foresee this being people getting, no matter where they are in the world, writing code or scripting that could be utilized by anyone. Oh, if it's open source, then they can go in and say, all right, I just made it. It's like apps, right? You know when apps like just blew up with smartphones? Everyone had an app. Well, it could be just like that for CMTS. We can have small little apps and widgets, or whatever I call it, that say, all right, for dynamic, here's a cool app that will actually set it up for you or help you troubleshoot, or maybe go from 24 channel to an 8-channel bonding group, or maybe take a service flow and push it to a smaller bonding group. There's a lot of functionality coming down the road when we start looking at software, software-based applications, or instead of just doing CLI. We still have the loyalists, the conservative guys that learn command line interface, DOS days. They know how to put in all the commands, and they're happy with it. Whether or not it's job security, I don't know. But things are always going to change, and people used to swear against GUIs because they're like, that's cheating. It's not loyalist type of stuff. I want to do CLI. I learned it, so I'm going to. I mean, things are going towards GUIs, no matter how you look at it. Yep. Make it easier.
I like GUIs. I'm good with it.
Graphical.
Hey, I remember when you still wrote a paper in WordPerfect, back when WordPerfect was a thing, and you actually had to know the commands to make it work. And I was like, this is not good. So basically, I was super excited when Windows came out and was so much better.
Yeah. So John, I think you guys were doing some work with Intel, right? Did you have a chance to spend any time with them?
That's an interesting thing. Is Intel is working on their FDX capable modem, so echo cancellation in the modem itself. Also, they are working with us on the FDX or the echo cancellation in the node itself with Capacicom in our RPD. The echo cancellation is a necessity so that downstream signal, there'll be no diplex filter in the node anymore, because FDX basically gets rid of diplex filter. Upstream and downstream could transmit and receive on the same frequency. FDX, full duplex access, is all about upstream speed. And the only way to get a higher upstream speed is increase the upstream. But if you increase the upstream spectrum, you start eating into the downstream spectrum. So if we can have the upstream and downstream overlap, it's pretty cool technology. As an RF guy, it's hard to understand. As an RF guy, you're like, how can I have upstream transmit at this frequency and downstream transmit or receiving at the same frequency without interfering? So it's pretty interesting. I mean, the terminology is kind of it's not an oxymoron. It's kind of a play because it's full duplex in the common part of the cable plant, but it's duplex at the modem itself. The modem itself can't transmit and receive at the same time, but you can transmit and I can at the same time because you might be far away from than I am.
Yeah.
Comes together at full duplex.
So,
you're simplex, I'm simplex.
Hey John, just so you know, your audio is going in and out a little bit here, but what we're showing right now on the screen is guys from Intel were nice enough to share some slides with us on the full spectrum, full duplex DOCSIS that they demonstrated live at the ANGACOM. And
yeah, so they had their thing is they had a nice presentation, as Mia was saying, the FDX over upstream and downstream, just like you're saying. They had a spectrum analyzer showing the communication in both directions, and FDX with their Intel chipset is basically the system on a chip. So they're the guys that are behind a lot of the RPD developments that are enabling this technology to come along. And then in their booth that they had, they were just showing the up converter, the cable modem, the whole system operating online. So it was a nice trial, and their claim is, first the field trial in 2018 for FDX in 2019. So it was a nice display that they had going on. So it was very good to see that, and we're very happy for them. So
after getting feedback in Germany, I think I started a presentation on FDX or 204. So it's kind of, I think it's going to be more of a business topic of, do I do FDX? Do I wait for the spectral modem? Do I have to have a spectral node? You have to go remote 5 to do FDX or 204 megahertz upstream. 204 megahertz upstream is in the 3.1 spec. And in Germany, they might not be willing to go node plus 0. They might stick to node plus 3. If they get rid of their carriage of FM radio over the downstream signal or cable they have today, they might end up just increasing to 204 and decide that's enough spectrum to achieve the speeds they need for quite a while.
Yeah.
So there's pros and cons to everything, right? So I'm going to write down, here's what FDX brings to the table. Here's the pros and cons, and here's what a 204 megahertz split will bring to the table.
Yeah, I think you bring up a good point for the European market, but also for, depending on what market you're in. If you're in New York City even, it's very difficult to go to node plus 0 because you're tearing up the roads and tearing up streets, tearing up sidewalks. It can be very, very complicated in order to push the fiber deeper to get to node plus 0. I think the great thing is, though, whether you go with DOCSIS 3.1 or you go with 3.1 FDX, we have a lot of options, and I think that was one of the themes at ANGACOM, was being able to have all these different options to go to higher and higher speeds. And so that is a very nice thing. We did a webinar yesterday with BTR where we talked of pretty much the similar thing, is there's so many different options just using plain old DOCSIS 3.1 with OFDM or going with FDX where you can go full duplex. And there's also other technologies. So we saw like GAIAX at the show that's doing this over-the-top sort of an overlay where we expand DOCSIS even further. We talked about this at the last show. There's just so many options with DOCSIS that keeps allowing us to extend it further. So if you can't go to node plus 0, there's options for you. If you can go to node plus 0, there's different options for you. So,
and like you said, I really think it depends on where you're at, the region. But I mean, there's some head scratchers even happening here in the U.S. when, like, some cable operators like, I'm going all fiber, and it's like, why? I mean, in your case, it doesn't make any sense. But in other cases, it does make sense. So, I mean, I think the nice thing about options is now you can do what makes sense for where you're at. And I'm not 100% sure which is the right or the wrong way, but I think technically people would argue, well, this definitely doesn't make sense for what you're doing, and this makes more sense for what you're doing. But again, it all boils down to options. And,
price. It all comes down to cost.
And understanding your options, yeah.
So I stopped into Alpha power supplies, and this has been my concern also. Node plus 0. Back in the day, us designing HFC plants, you'd have a 15 or 22 amp power supply located at the node, and then you supply power down to the amplifiers. So what happens when you have no amplifiers and the node only requires 2 to 3 amps? Now, do you put in a smaller power supply? Do you put a centrally located 22 amp power supply, 90 volt, quasi square wave, somewhere else? How do you get the power down the fiber? You don't. You can't get power down the fiber. So do you do existing coax, so you just leave it in the ground or in the air and just use it for power? So I talked to these guys, and they said, well, we're going to have a 5 amp supply at every single node if we want to do that. But believe it or not, some of these node plus 1 or node plus 0 environments, they're getting rid of the amplifiers, but they're putting up hotspots. So now you have other active devices
pulling current
on the cable plant. Yeah, pulling current. So they say, and I never really thought about that. So you could still have a case where you need a 90 volt, 22 amp power supply because you're providing to the node and you're providing to all the devices that are hanging off that node. An amp here, an amp there, an amp here. I mean, this is an amp 3 for the node. That's a 15 amp supply right there.
Yeah, I hadn't considered that, but yeah, some of these, especially when, and I know Alpha, a great company. I know that they're also really looking at doing backhaul for, as you say, whether it's a hotspot or whether it's an LTE hotspot, or now looking at the 5G as well. That becomes something that is actually generating quite a bit of power, and so you need that power supply to do that. That's really interesting thing to start considering as well.
This is the little stuff that we keep forgetting about, It's like we can talk about technology, but sometimes you get back to layer one, which is powering everything up. I mean, it's is it a greenfield or is it a brownfield? If it's brownfield, you still have some coax up there in the line. Maybe you could utilize that as backhaul for power, We even talked about when we had, I think, Daniel on last time about the 10 gigi over coax. And how we could utilize maybe some of the existing coax for 10 gigi transport. I mean, I think you have to take a big picture view, and then you have to dive deeper into the weeds to find out exactly how this is going to work. You might find out it doesn't work the way you thought you would. You brought up last week, I said, I thought that idea of blowing out existing coax and throwing fiber through the coax as like a conduit sounded like a great idea, but you said it takes the customers offline for that amount of time.
Yeah.
And that could be a non-starter.
Yeah.
And I didn't really think about that side of it,
Yeah, it can be problematic. So you mentioned timing earlier, and we're talking about cellular backhaul. I was surprised at ANGACOM how many times people were asking me about what is the timing of DOCSIS 3.1, or how does Remote PHY versus MAC-PHY impacting that? We've had some of our listeners write in and say, well, what is low latency with AQM in DOCSIS 3.1? So that is something that you mentioned before. I'd like to, can you give us some more background on what you guys are doing to address timing? And does it make a difference whether it's RPHY or MAC-PHY? What's your background or experience with that so far? Because timing seems to be something that a lot of people are asking questions about when they're looking at 4G and 5G backhaul.
So it's almost a 3 or 4 pronged approach I'm seeing. One of them is the DOCSIS protocol.
Can you repeat that? You broke up right at the most important part.
Yeah. Around and then connected my microphone. DTP, DOCSIS timing protocol. It's part of the spec, and it provides 5G timing source over cable itself. I don't have all the specifics. Maybe we should focus on that on our next hangout. Just mobile backhaul, low latency. So I'll give you some overview of some of the stuff. The DTP is one of them, DOCSIS timing protocol. Another one's called a DOCSIS bandwidth report. It's supposed to be for latency optimization for mobile over cable. And I probably go into that deeper later on. There's 2 other things. I think this comes down to sort of what Mia was talking about, the active queue management. There's a multi-queue grant sharing part according to the spec. It is for bandwidth efficiency optimization, but we took it a step further, and right now, you brought up Intel. It has to be something in the modems will support. There's something else called multi-queue. I can't remember. Proactive upstream granting is one of them. And I'm.
It's also the request grant cycle, right? So if we narrow, because every time a modem wants to send data, it has to send a request to the CMTS to get a grant back. So if we can shorten that cycle, that helps too. Isn't there something that's done in the CMTS to help improve that?
Yeah. So if you look at how DOCSIS works, and that was the whole argument against MAC-PHY
versus Remote PHY. So yeah.
I think John, your audio died again.
Going in and out.
Yeah.
Make sure how's that? Here's the bird.
Yeah. The bird keeps whispering in your ear.
I'll hold it up like this. How's that?
Try to be the star of the show.
So when a modem makes a request, that's to send it all the way back to the MAC chip, and whether that's in the node itself, remote MAC-PHY, or if it's in the CMTS core, remote PHY, and the CMTS core is 1,000 kilometers away through a digital optical link. The modem makes a request that goes all the way back to the CMTS, and the CMTS has to wait for the map advance, some time delay there to process it. And then on a downstream map, the cable modem will get that downstream map and says, hey, I have this time to send. So modems just never just send when they want. They have to send a request to be allowed to send. So it's a three-way process, right? Send a request, get a downstream map, and then send your actual traffic. So that round trip time can take a long time whenever we have this long delay in between. Normal DOCSIS was limited to about 100 miles of fiber because there was a limit of 8 microseconds of delay, 0.8 milliseconds.
Mm-hmm.
0.8 milliseconds? That's 800 microseconds.
It was 800. I thought it was 800 milliseconds, isn't it?
No,
800 microseconds. Yeah, 0.8. Yeah, 0.8 milliseconds. Yeah.
Or is it 8? Now I'm confusing myself. Either way, when you did the math for velocity propagation through fiber and all that other stuff, you came up with 100 miles of fiber, or 160 kilometers if you convert to metric. So about 100 miles of fiber. That was a limitation of a DOCSIS plan. Now we're saying, well, if the optical link is digital, going from the PHY chip to the modem itself, it's all coax. It's never going to be more than 5 or 6 miles, if that, right? Yep. Coax is what, 1,000 feet, 500 feet, you're done. So it might be less than a mile. But the digital link, 3,000 kilometers. So the question is, the modem makes a request, it has to go all the way back to the MAC, goes through that digital link. How do we get that modem to get grants more often or quicker? So we can do something called proactive grant sharing or proactive grant service, where the modem makes a request, the CMTS knows that modem has a higher upstream rate because of the CM file, and it can say, all right, on this downstream map, you asked for so many slots of time on the upstream, I can give you more. I can proactively estimate that you're going to need more, and no one else is asking for it, so it's kind of use it or lose it. So I can give you more grants, and that's one way to get around the request grant cycle. When I did my own testing with remote PHY, I noticed with DOCSIS 3.0 modems, I really didn't have much of a problem because with 4-channel upstream bundling, you got 4 channels doing upstream requests anyway. So I had a lot more traffic. So I was able to get more speed with a 3.0 modem. A 2.0 modem, totally different story. Request grant cycle was kind of slow. So we came up with this other thing called DOCSIS Predictive Scheduler, DPS. And that was a Cisco, I would say, proprietary feature that allowed the CMTS to give out more grants and be more predictive. What I found out for the low latency stuff, this is kind of different. It's not just saying just add more speed. Just because you add speed and a bigger pipe doesn't mean your latency is any better. Latency, some people would just do a ping and say, oh, well, the ping round trip time was 10 milliseconds, which is pretty long, and I want my ping, ping pong, up and back ping to be, less than 3 milliseconds or whatever it happens to be. You can find that you have really fast speeds, but your ping is not developing latency. Seems pretty slow. So we have this low latency queuing. We have this proactive grant sharing, the DOCSIS predictive scheduler, bandwidth report for mobile, DOCSIS timing protocol for 5G backhaul. There's like 5 different things that we'd have to go deep, kind of understand. I think it's going to come down to the proof is in the pudding.
Yeah, so you think all these put together makes it so it's not going to require to go to MAC PHY. We'll still be able to do remote PHY, and we'll still be able to manage 5G backhaul, and so that kind of, we can do either or then.
Yeah, and then some people would argue it's like, are we putting the horse, the cart
5G's not here yet, mean?
That's one of them.
Yeah.
But the other one, is if I have a network that is 1,000 kilometers of CIN, digital, how many networks do we feel are going to be like that? I bet you 90% are going to just which is less than 20 kilometers of fiber. They're just going to go to a digital link. The digital link, you get much better MER readings, much higher modulation can be run.
Hey, John, your audio. It died on us again.
Yeah.
Hello?
It's okay.
No, it's not.
Well,
and you're on a phone now, aren't you?
We'll fix it for next time.
I feel bad for your friends and family.
Yeah.
So the only place this is going to be a concern is if I have an environment, an architecture, where I do want to have the cloud or CMTS core centrally located and then go across the country or across the state to a remote PHY device. And then we have to start talking about
yeah, then it becomes really problematic.
Yeah, and most of the systems are probably going to be as they are today. 20 kilometers of fiber. That's it. Most systems, 30, 40 kilometers. We have customers in Arizona that have long 70, I think Midco, North and South Dakota. They have some 70-mile fiber runs with EDFAs and stuff like that.
Yeah.
But they're the exception.
So, okay, so the other thing that was big at the show, I think, was all the data. So we had a whole big data presentation. We had the companies there were Microsoft, Nokia, Guavas.
Something like that. Yeah.
Guavas were also involved in the presentation, and the thing that we're seeing, my angle on the presentation was just from what we're collecting from DOCSIS 3.1 devices is absolutely massive. The other companies were looking at things we're collecting from like subscriber data, from what subscriber usage habits are. Everything that we're pulling in is absolutely massive, and we're analyzing this data with big data analytics in order to make more intelligent decisions to see what subscriber habits are. From a P&M standpoint, we're collecting this massive amounts of data that we're from OFDM channels. We're getting like 8,000 sample points when you look at receive MER per subcarrier and stuff. This stuff doesn't fit into traditional databases. You can't analyze this in the traditional ways that we used to. So that was really the concept of the whole big data presentation, is how do we deal with these massive amounts of data that we did not used to have to deal with before. And it sure can't analyze it with Excel spreadsheets anymore. But the only thing you can do with Excel spreadsheets with this is really quantify how much massive amounts of data that we have. So
maybe we need to bring Google in.
I was surprised Google wasn't there presenting, but I think they just didn't make the panel.
But they would have to admit they're gathering data from all of us.
Yes. I'm sure they were listening.
They
were eavesdropping.
I think.
But
go ahead. Sorry.
Go ahead. No, you go.
Ladies first.
No, I already forgot what I was going to say. So go ahead.
So I agree. It's like we have all this information coming in, but you sort through it, and that's sort of what Google's bread and butter is. They figured out algorithms and code to figure out how to decipher or bring that information together and how to look at it intelligently and sort it and grab what you need. When we first started looking at DOCSIS 3.1 graceful profile management, one of the things we said was going to be needed for 3.1 modems to do different modulation on the fly in the carriers and all the other stuff was SDN, software-defined networks, and a server sitting in the background collecting all 8,000 subcarriers of every single modem every single minute or more often, and make decisions. Now, as we look at DOCSIS 3.1 modems in today's plants, we're finding 60 to 70% of them could do 4K QAM. There's no problem. The MERs are decent, really decent. The other modems will be relegated to a lower modulation, but the CMTS already keeps track of 5 of them. The CMTS can do like 7 modulation profiles, but the modems, the RAM that will hold on to 5 modulations and not have to do a DBC or anything like that, dynamic bonding change. If they report a low MER, they can just drop to the other modulation. So our idea before of having to have all these different modulations for all these different modems, right now, 3.1 is pretty robust. With the LDPC, with the mod profiles we're seeing, with some of our best practices, I don't know that we need to have a million different profiles for a million different people. You understand what I'm saying? It's working out really well that most guys could do a full 4K profile, ignore maybe the outlying subcarriers that roll off, or 2%, or I'm saying ignore 10%, because LDPC and the interleaving of frequency and time seems to be really robust. And we're saying, you know, the MER is very conservative for the threshold when it changes modulation. So we tell people, you know, you could adjust that 2 or 3 dB on the CMTS. And you don't need to make all these special mod profiles. People are asking, should I avoid the LTE spectrum? Should I make a mixed mod profile? And LTE will fall. And we're saying, you know what? We're finding that it's pretty robust. I would still, you know, announce prevention with a pound and a cure. I would put my PLC somewhere really clean.
Yeah, keep the PLC away from things like LTE band and places where you're going to have obvious interference.
Yeah. Why tempt fate, right? I mean, the PLC is 16 QAM, right? So it's going to be really robust. But I don't want to put it in a roll-off area. I don't want to put it where LTE I know is going to be. But I mean, I put it somewhere clean. I don't need to totally avoid the potential LTE interference spectrum. We're finding that you're pretty safe just to run the same modulation straight through. The CMTS does the time and frequency interleaving, and even if it's 18 megahertz of LTE interference, 192, 18, that's
plenty
less than 10%.
Plenty of space to put it. Yeah,
that's like 9% of your spectrum where LTE could, and they can actually make up for it anyway. So I'm not advocating special mod profiles or exclusion bands or any of that. I know we're still being very cautious because it's new.
Yeah, but I think, I mean, that's what we saw at ANGA was, and the stories that we're hearing is that more and more operators are deploying it, and it's working really, really well. And what I'm seeing what operators are doing is typically they're just putting out 3 profiles, you know, one 4096, one 1024, and one 512. So, and that's working pretty robustly.
But they probably thought their profile A, or we call profile 0, the control. The control profile, and that's by 256 QAM. Mm-hmm. I assume. So have the control profile 0 QAM, 512, a 1K, and a 4K. I'm saying, hey, why not do a 4K, a 2K, a 1K, a mixed? If you happen to know you have some roll off at 750 or something weird, it could be per household, right? Someone has a house amp that rolled off. And then you have your control profile 256 QAM. So it's because the modems can actually store all 5. And if the modems store all 5, it'll just use whatever it needs. And if it happens to need a mixed profile, it'll use that one you made, you know. Right. And I say mixed, I say it might be a special case where you know that some house is 860, you know.
You understood what he just said because I didn't.
Well, parts of it. He's breaking up a lot. He needs to get a better phone.
It's just like you're going like this. It's like I don't know what you're talking about, man.
All right, so taking a change, we have a question comes from one of our listeners. It's a little basic, but I have an answer for it because I've seen this before. I'll be interested in what your take is. It says, do you have any examples of forward carriers affecting a return path due to poor termination? Is common path distortion the same thing? We have 4 bonded upstream carriers, and sometimes when it looks like it's a big fat QAM carrier right under the four carriers raising the noise floor. So basically, I think they're seeing return path on the return, but they're seeing this associated, they're thinking this is terminators, it's happening at the end of line. I've seen this before.
And it's a conversation between a tech and a maintenance tech, and they're basically having a debate on who is right. He thinks that I believe the maintenance tech feels that the terminators, he's thinking they're terminators, and the tech feels that they are any connections secured to the center seizure screw, mainline connectors, or amp module, not tightened down. Mm-hmm. So,
and what is it leading to? I mean, what is the result?
It's leading to the forward carrier affecting the return. So they're seeing like a 6 megahertz channel underneath their QAM channels in the return.
Just one? I don't understand. So how do they know it's a forward channel in their
Well,
upstream.
they say it looks like a big fat QAM channel right underneath the 4 carriers. It's raising the return path noise floor. So they're seeing the noise floor being raised up. So it looks like an elevated noise floor in the return.
Oh, yeah. So you made it sound like it was a 6 megahertz haystack showing up in the upstream.
Yeah, I think the way they're describing it is just like a big elevated noise floor in return. But it's looking like QAM channels, but they'll be all together.
I mean, and you know as well as I do, QAM path distortion. When you go full digital downstream, you're taking multiple 6 megahertz chunks, and you're intermixing them to make 12 megahertz of noise. It's F2 plus minus.
Yes.
So your entire upstream noise floor will raise up.
You can't tell you won't be able to see that they're actually QAM channels in the return.
Correct.
It's just going to be a continuous elevated noise floor. If you have an analog plant and you get CPD, you're going to see 6 megahertz spikes in the return. Every 6 megahertz, you'll see those clear as can be. And if you zoom in on a spectrum analyzer really, really close, you can even see closer that not only is there 6 megahertz, but there's even little side lobes on those 6 megahertz. This is in a pure analog plant. When you go to a pure digital plant, you're not going to see little 6 megahertz humps. You're just going to see this elevated noise floor, because like what John was saying is you get this intermodulation where 6 megahertz intermodulates with 6 megahertz, and now it becomes 12 megahertz, and then 12 megahertz becomes 24 megahertz, and it just becomes a noise floor. So that's what you're going to see with CPD in a return path with an all QAM system. It's just one big elevated noise floor. We see that constantly. The thing that I really like about this question is when you have a bad terminator at the end of line, and we see this all the time with P&M systems, is it creates a really nasty micro-reflection. So your modem's signals will start bouncing back and forth in the entire system, and it causes a really difficult micro-reflection to find, because you always start thinking about micro-reflections and echo cavities, and you start thinking that you have to start moving forward towards the CMTS to find out where that micro-reflection is being caused by. You think it's going to be like, it's going to be at the amplifier, line extender, or maybe some mainline tap moving forward. But this end-of-line terminator, we've seen this so many times, is going to cause this crazy echo cavity. And so one of the things that we practice and we teach when we're talking about proactive network maintenance is that if you're working at the end of line, always go back and check that terminator. Make sure that terminator's make sure it's terminated. Then you do have a terminator at the end of the line. Or make sure it hasn't been blown out, like it hasn't been destroyed by lightning or something like that. Or maybe there's just corrosion on it, as this listener is talking about. So it can cause CPD, like what this listener is saying. It can also cause really bad micro-reflections, which are just echo cavity, causing all of your P&M modems to go red. And we've seen it so many times. We always teach, look behind you when you have this problem. So it's a big problem.
So when you broke it down to echo cavity and the end-of-line terminator, was the cavity from the modem to the terminator? Where was it bouncing back and forth?
You never. I mean, the modem transmits up into the mainline tap, and heads towards the CMTS. But what's happening, I believe, and I haven't really explored math enough on this. When that terminator is unterminated, your span of cable is no longer a 75 ohm cavity. It's it's some other termination. And so when that signal is going up and into the tap, that tap is no longer terminated. So some of the signal now heads to the amplifier, some of it heads to the end of line. When it heads to the end of line, it's not being attenuated. It's not going into a 75 ohm termination. It's seeing an open. And so when it hits that open, it gets reflected back to the amp, and now you have this echo cavity where the signal's bouncing back and forth.
So the modems off of low-value taps are going to be worse, because low-value taps have less port to output isolation, right? You get to a 4-port 11 dB tap, It's really, I think, just a splitter in there at your break-off point,
yeah.
at retro coupler. Yeah, so basically the signal goes up towards the CMTS. Some of it goes back feeds, hits your end-of-line tap that might not be, well, you could even say a 2-port 4 dB tap. The housing doesn't have a terminator, but if the spigot doesn't have a terminator, that's basically an unterminated tap as well.
Absolutely.
You know, so it reflects from there and comes back, and it's only 4 dB of loss in the tap itself. So, yeah, I agree. That's why I always used to say, it's not just housing terminators. You should terminate tap spigots, especially low-value taps.
Yep.
11, maybe even 14, 11, 8, and 4.
Yeah, but this gets back to just the fundamentals, and we're going to be doing some more of this. I've got some stuff I'm working on with another vendor.
We actually mentioned it back after the show after the SCT show. We talked about that we wanted to do some stuff with connectors.
Yes, so I mean, just getting back to the basics: connectors, terminators. If these things are not working and we start to get into FDX DOCSIS 3.1, it's so important that things are terminated and connected.
Yeah, I think the point is that you can have the best technology in the world, but if you have a crappy connector, it doesn't matter.
It just all falls apart so quickly.
Yeah.
So,
I mean, we're all sitting here talking about technology and doing fiber deeper, but it's still coming down to
and worry about nanosecond timing.
Yeah.
And it'll be that little terminator that just makes it all fall apart.
Yeah. I that's a good point. I stopped over at who was right beside us at our booth. They gave me a jumper. It was kind of interesting. It was a push-on fitting, but it was a jumper with a push-on fitting that was crimped on, compression or crimp.
Didn't you have Fritz box next to you?
That was right beside, but across was Belden. Who makes the cables and stuff?
I don't know.
There's lots of people.
Yeah.
That's
PPC.
pretty bad. Yeah, I think it's who it was. Was it PPC? Maybe it was. No, I'm going to give a shout out to the wrong people. So it was interesting. Their push-on fitting was a push-on, but it had a jacket around the outside of it that you then kind of screwed on. So the push-on fitting would go on, and then it could actually tighten down.
Oh, very nice.
What's interesting about it is in other countries, the F connector is not quite standard. So sometimes you get an F connector that's a little bit bigger than you think. The F connector doesn't seat well. Comcast has been saying that, and this is really getting anal, if you will, they feel like if you do a disconnect, the last thing that you disconnect from the spigot would be the ground. Now, we've always preached that when you make an F connector, the center conductor should stick out a little bit, because we always feel like we want the signal to have good connectivity inside the clamshell or whatever's inside. But they're actually saying maybe it's better to have the center conductor shorter
inside.
Than
The
because you want the last thing to disconnect, ground.
That
so
actually makes sense.
Ground,
that actually makes a lot of sense when you think about it.
It's a lot more impulse noise if you disconnect ground first, and then the center connector still has connectivity.
Yep.
So it's impulse noise like that, disconnect, but what if you're unscrewing it and then you pop it out? I don't know. I don't know what the answer is to this. It's like, do we actually need to redesign F connectors now?
Yep.
No.
I would rather have a better ground and no center conductor connecting than just have the center conductor connecting and the ground not connecting. And that's what we talk about all the time with loose connectors.
But if I need a certain amount of center conductor to go into the other devices, now does that mean I need to make my outer threads deeper?
Yes.
So
I'd rather have that. I would absolutely rather have that, because from a P&M standpoint, we see that all the time. Loose connectors. Loose connectors are a horrible thing. It lets so much return path noise into the plant.
And if that's the case, should it be, because I hate just screwing on F connectors for like 20,000 threads, right? It's almost like we need a push-on thread. So you push on part of it, and then you just thread the last 5 threads, and it gets it the rest of the way in.
Dude, I can't help it that you're lazy.
I know.
Wait, John, you have all those muscles, and those are like, oh, my little fingers.
Yeah. I ain't got muscles in my fingers. That's the problem.
All right. Anything else we want to cover from ANGACOM?
We digress. As we digress.
Yes.
I'm trying to think who else. There was a lot of Chinese companies selling modems, CPE devices. A lot of good beer.
Yes, beer is good.
Yeah. Like I said, I didn't get a chance to really walk around a lot. I stopped in at ANGACOM. They were showing some stuff about common path distortion, how they could now do common path distortion tracking on a digital remote PHY without having to wait for NDF and NDR support. So NDF, narrowband digital reverse, narrowband digital forward, digitizing analog signal for test equipment. They're basically going to query the upstream chip that is in the remote PHY device to get the spectrum analysis and kind of tag along with their common path distortion troubleshooting. I think that was kind of interesting. I stopped at Viavi's booth, talked to them. We talked about SCTE coming up. Believe it or not, SCTE is only 4 months away.
Yeah, it's coming quick.
We're end of June, July, August, September, October, 4 months away. So we're talking about what will we support there and what do we want to show. I think we're going to provide a signal to Viavi's booth so they can do stuff with 3.1. So I thought that was kind of interesting. I asked some of the FDX, I would like to see if you guys could do an ingress under the carrier for DOCSIS 3.1.
Yep.
Because when you do FDX, you can't see the upstream signal improve. You're doing FDX. Yeah.
Yep, absolutely.
Basically hiding it. So if you could do like an ingress under the carrier with 3.1 signal, then I could prove the 3.1 upstream is there.
Yep. We are on it.
Very aware of it, right?
Absolutely.
So that's basically the stuff that I checked out and looked around and asked about.
Mia,
Nope.
Anything you want to?
No.
All right. Well, I just want to give a shout out to all the folks at ANGA who made such a great show. I think that was fantastic. Couldn't have been a better show. So
Yeah, I guess I will do a quick shout out also to the SCTE in the UK.
Yeah, SCTE UK.
Yeah, they were, and then also several Liberty Global people who we met and had a fun time talking to about different
absolutely.
things. So they were fun, and of course also Karsten and Karin did a great job. So
yes.
ANGACOM war sehr gut dieses Jahr. Okay.
Gesundheit. That's all I know.
All right. All right.
Okay.
So, John, thank you so much for your time today. Mia, thank you for your time on the show. This is a great episode. Our next episode is scheduled for July 20th. Upstream levels for DOCSIS 3.0, DOCSIS 3.1, attenuators at higher frequencies, especially 204 and FDX, and how RPDs come into play. So everyone, we do our best to bring great audience technical content every month. You can watch us on the air, live, on YouTube and voltfirm.com/broadband events. So download our audio if you just want to hear our voices and not watch our mugs. Thanks everyone for joining, and catch us next month.
And if you watch us on YouTube, please subscribe.
Yes, hit that subscribe button. Take care everyone, and so long.
All right. See you later.
Bye.